All right, 11-4 overview, part 2. In the other part of the video, I stopped about here where we were calculating the z-score, which is just how many standard deviations is a score above or below the mean. And so if we come back here and we take an example, let's go back to this example. So if you have two different scores here, we've got that 11, 20, and that 23. And remember our other data that goes with it. For the SAT here, the SAT mean is, remember this is your X, your data point. And the mean here for this SAT was this 1,000. And the mean over here for this ACT is a 21. And then the standard deviation for each of those, this lowercase sigma there for a Greek letter. So your standard deviation over here is the 200. And then your standard deviation over here for the ACT is this 5. So remember how we did that? We figured out how many points they were above or below the mean. So if you look at these two, the 1120 is 120 above, and then divided by, let's stay consistent with my colors here, sorry about that. So if I take my data point, the 1120, and subtract away the mean, we figure out that she was 120 points above the mean, and then divide by that standard deviation. And so you'll get a z-score there of whatever that is, but it's above the mean. So the mean, if you're right at the average, is going to be 50%. So we know we're above that. We'll look that up here in a minute. And then over here, she had a 23. If we subtract away the 21, so she was 2 points on the ACT above the standard deviation, and then the standard deviation there was that 5. So if you divide by that standard deviation, so again, remember how that formula goes. It's your data point minus the mean and divide by the standard deviation to figure out, they call that the z-score. How many, and it's really just the number of standard deviations you are above or below the mean. So this 2/5 would be what, 0.4. And then what was that, 120 divided by 200, just grabbing my calculator here to do that. And that's 0.6. So from those two things alone, we can see that this is actually better, higher, compared to the average or mean than this is. So if that was the question. But then the next thing, let's take a look at, and these two only have 1 decimal, but you know, depending on what you're dividing by here, this could have had a couple of decimals. But let me go show you how you use a z-score table to look these up. So let's go over here. I've got a couple of different examples of this. This shows you, so we were over here, someplace in here on those two, 0.4 and 0.6. If you think about it, and remember, this is your 50% right in the middle, below 50, above 50. But then let's come over here. So this table here, let's say we were doing the 0.4. So I think I see it over on, these are just one big table with this scroll bar. Didn't all fit in here so you could see it. So let me just get those two kind of out of the way so I can make this one bigger for you. And if it was something smaller than a 0.4, oh shoot, I need this one, I think, so you can see the headings at the top. All right, so you've got your z-score, and then this would be your percentile. So if it was a straight 0.4, you see this 0.155. So the 0.4 came out to a 0.155. Well, what does that mean? Because if you come back to it, Like, that seems awfully low to be a 15%, a 0.4. If you come back here, so 0.4, well, first of all, 0.4 is above the 50%. So again, we had that 0.4 was 0.155. 0.4. This 0.4 is 0.155 in that data table. Remember, this is a positive. So that means that we're above here, so it's got to be greater than 50%. So what that is 50% plus the 15.5% to make that at a 65.5%. Well, what if it had been on the negative side? Like, what if it had been over here at, like, say, negative 0.4 instead of this positive 0.4? So that would just mean how much you had to go to the left of 50% to calculate it. Now let's take a look at one of the other type of data tables that you can get with these z-scores. So sometimes it'll look like this one. So if I know that it came out to, in this example right here, I've got, let's say it came out to a positive, my z-score. I was 2 and just a little more than 3/4 standard deviations above the mean. Well, how do you look that up in this table? So if I'm 2.7, and the second decimal comes from the top of the column, 2.76. So there's my 6. Here's my 2.7 on the left side over here. Okay, and then you go to where they meet, and this gives you your percentile. You don't have to do that adding and subtracting from 50% to read the table. And then what if it was a negative? So these z-score tables like this, a lot of times they're separate. And so this example, what if we were 1.35 standard deviations below the mean? That z-score is negative 1.35. That's what that means. The z-score, or 1 35/100ths of a standard deviation below the mean. So then what does that come out to? So if you look at this, 0.08851, that would correspond to 8.51%. I believe that's the last part that I wanted to go through to make sure you've seen a couple examples of those z-score tables to understand how you might have to read those. If you need more help with that, you know, you jump on YouTube. There's a lot of other explanations out there, and you can get a little more specific detail on just exactly what it is that you want by doing that. So good luck with z-scores and z-tables. It's just the number of standard deviations you are above and below the mean.